Hey everybody, it's Ripley again. We're in section 2.3 and we're going to talk about the limit laws. And then I sort of facetiously put over here, plug it in, plug it in. That's your first law. Just plug it in. If I'm taking the limit as x approaches 3 of x plus 3 over x minus 9. Whoops, let's go x squared minus 9. Plug it in. See what happens. Oh crap, I get 6 over 0. Whatever shall I do? Now, what do we know to do? Well, we're going to do a little algebra. When in doubt, do algebra. All right? If you're just sitting around and you're trying to figure out what is going on, if I got x plus 3 over x plus 3 times x minus 3, notice, gone, and I end up with the limit as x approaches 3 of 1 over x minus 3. Ah, crap! When I plug 3 in, I still get undefined. It doesn't exist. So this limit doesn't exist for this function. The limit is x approaches 3 of x plus 3 over x squared minus 9. Doesn't exist at x equals 3. Remember, these limits are equal, but these quantities are not. Algebraic cancellation produces holes. It just so happens that I didn't get the right hole in the right place. That sounds a little disturbing. Okay, let's do a little math. I gotta warn you guys. We've got some construction going on underneath me, so it may be a little bit loud, but that's okay. All right, let's start nice and easy. It's rule number 1. All right, these are the actual laws. You've seen these before, but we're not going to get too crazy about them. The limit as x approaches a of f of x plus or minus g of x. Remember the limit of the sum. So this is the limit as x approaches a of f of x plus or minus the limit as x approaches a of g of x. In other words, the limit of the sum is the sum of the limits. Okay? The limit, we proved all of these way back in the day, back in pre-calculus. If you haven't seen it before, though, it's a good thing to see them. The limit of a constant times a function, limit of a constant times a function is just equal to the constant times the limit as x approaches a of the function. In other words, constants just get pulled out. That's really vitally important. Number 3 is the limit of the product. Limit as x approaches a of f of x times g of x equals, as you can probably guess, the product of the limits. So I take the limit as x approaches a of f of x times the limit as x approaches a of g of x. Now you may ask yourself, really, why are these limits here if they're so intuitive? You know, if it just takes a little bit of intuition to be able to do these. Well, remember, it's mathematics. We've got to make sure we dot all the I's and cross all the T's. So now we have these laws that say, hey, I can bust a limit up. If I got a product, if I got a sum, if I got a constant, there are ways that I can simplify my thinking when I'm dealing with these. You can probably agree that if I take the limit as x approaches a of f of x over g of x, this is a limit of a quotient, by the way, is the quotient of the limits, as long as limit as x approaches a of g of x, where the limit as x approaches a of g of x can't equal 0. Oops, not f of x, of g of x can't equal 0. All right? So what happens if it does equal 0? Well, we already talked about that. We do some algebra. Now notice, had this been, let's change my colors a little bit. Had this been a minus instead of a plus, I'd have had a minus there, and instead of these two terms canceling, these two terms would have canceled, and life would have been good again, right? So that's kind of the rule. The first thing that you always do with limits is, without even thinking, plug it in. If all hell breaks loose, do algebra. All right, so that's sort of that's the poor man's dealing with limits, okay? So where am I? 4, 5, where am I? Oh, 5. Nah, I'm on rule number 5. Now again, we talked about all these. If you need me to clarify these further, I would be happy to do it. I just want to make sure it makes the list so we don't get too crazy. The limit as x approaches a of f of x raised to the n can be written as the limit as x approaches a of f of x to the nth power. That's a super, super powerful thing to be able to do, because that leads, remember, this power, any exponent can also be written as a radical if this thing's rational. You know, if it's 1/3, then it's the cube root. So basically what this also tells us is that the limit as x approaches a of the nth root of f of x, it's exactly the same thing, is equal to the nth root of the limit as x approaches a of f of x. All right, so that's it. I mean, those are the rules that we get to be able to do, that we're going to play with. All right. The bottom line on all of this is you want to make sure that the first thing that you do is plug it in. So let's just do a quick synopsis. Then I'm going to show you a couple of interesting problems that you may not have seen before, and then we'll be done. It's not a very long lecture this time, and tomorrow in class we'll do, or the next time we meet, we'll do a bunch of problems. Okay. Excuse me. All right. The first thing is, let's do. All right. So dealing. I'm stammering over here. Sorry about that. Dealing with my stupid cell phone's going off. A limit. Step 1. Plug it in. Plug in a. In other words, remember this limit is the limit as x approaches a of f of x equals, plug in a. See what happens. All right? If we get a number, if we don't have trouble, wow, that's a bad T. Speaking of trouble, you're done. You're done. Part 2. If trouble, if you run into trouble, do algebra. Algebra. Use calculator. Use calculator, etc. In other words, use your other skills. Exhaust your other skills, etc. Okay? All right. That's the bottom line. So basically, plug it in. If all hell breaks loose, do something to try to deal with the hell breaking loose. All right? There's 2 other things that I want to cover, but first let me show you a trick that you may or may not have seen before. All right, what if you've got the limit as x approaches, say, 1 of, it's just kind of arbitrarily chosen, of square root of x minus 1 over x minus 1. Well, if I use my plug it in, what do I end up with? 0 over 0. Bleh. Bad. So I got to do some algebra. The problem is, what algebra am I going to do here? Do you see how there's not a whole lot I can do with x minus 1? Well, maybe there is later, but I'll show you that little trick as well. The problem is the square root of x minus 1. If I could somehow do something fancy here, like maybe rationalize the numerator. Now, have we rationalized the numerator before? We did a bunch of rationalizing of denominators because we had to, but we've never really done it with the numerator. So let's see what happens if we did. I've got the limit as x approaches 1 of, speaking real good math here, not very good English though. I'm going to multiply by a goofy looking 1. Remember, I can always multiply by 1 if I want. All right? And what do I end up with? Well, let's see. I end up with the limit, the limit as x approaches 1 of, now what do I have? I got x minus 1 over x minus 1 times the square root of x. Went a little crazy with my radical there. Sorry about that. I went a little radical with my, oh God, that's just a bad joke. I'm sorry. X plus 1. And look what happens. Gone. And more importantly, I end up with the limit as x approaches 1 of 1 over root x plus 1. Dun, 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 dun. Now, had we looked at our calculators, if we graphed this thing, we looked at it, hopefully we would be able to see that, again, at 1, this thing doesn't exist. There's nothing I can do to make this thing exist at 1. However, its limit does. So if we graph the thing here at a half, what we've got is we've got something going this way. Okay? All right. So let me show you another real quick, and then another way to do this, if you see it, if you think about it, couldn't x minus 1 actually be considered a difference of 2 squares? Now, you may not think of it in those terms, but think about that. Isn't this the square root of x squared? And isn't this 1 squared? So I could have rewritten x minus 1 as root x minus 1 times root x plus 1, right? And then when I throw in this guy on top, I would have had those things cancel, and I would have ended up with exactly the same term. Just another little clever algebraic trick. All right, last but not least, let me give you a theorem, because theorems are fun. All right? We're going to do the squeeze theorem. The squeeze. You know what? No, we're not. We're going to wait. We're going to do that tomorrow. We'll do that in class. I like to do theorems with you guys because most of them are super intuitive. All right, so in that case, have a good night. I hope you enjoyed the video, and I'll see you tomorrow. Bye-bye.